Alright, so for those of you who have been watching my videos, you'll recognize that this is not my normal lab setup. Currently, my old workshop was in the basement, which about a month ago was flooded. So it's all been packed up, and we're in the process of putting it all back together. But in the meantime, I thought I'd get this video out. It's been quite a while since I put any videos out, just to get this out. What I've got here is I got a pair of these HP. These are HP 8484 RF power sensors, and these are the low power signals, 100 picowatts to 10 microwatts of power. And of course, when the basement flooded, these were completely submerged, and they don't want to work right anymore. I've got a pair of the, I guess what you call the intermediate power range sensors. I've got an 8481 and 8482 HP power sensor. Both of them seem to work okay. They have a slightly different type of system, type of sensing mechanism. I think they're thermal resistive type sensors, whereas these are diode detectors. But anyway, those two seem to work okay, but neither of these power sensors seem to work. And the issue that I'm having is that they won't zero anymore. Of course, they both worked just fine before they got submerged. So I know they were working. They aren't working now. So I've got it taken apart. I've got this one taken apart. This one's got I don't know. It's got tamper seals on it. So I figured, and this one did not have any tamper seals. So I figured I'd try that one first, and if we can get it working, then we'll crack into the other one and do the same thing. But anyway, so what I've got is I've just got a little test set up here. A couple of things on my little workbench. We've got a RF signal generator. We've got our HP, our power meter, and I've got a multimeter up there to take some readings. And I've also got a copy of this service manual from HP. It's for the HP 8484 power sensor, and it's got some good information in it. It's got a schematic diagram of the power sensor itself. I know this is kind of dark. The lighting in this room isn't very good, but if you just follow along with me, it's got a schematic diagram with a pinout, and it's also got lots of information about the way the sensor works, theory of operation, and it's got a section for troubleshooting. So what we're going to do is we're going to walk through some of the things in that manual and take some readings, and we can determine whether it's got a bad sensor or if there's some other problem. I've got my suspicions as to what the problem is, and we'll get into that a little bit further on down. Alright, so we got the unit. I've got it set up. I've gone ahead and disconnected it from the signal generator, and we'll go ahead and try to zero the unit and see what happens. Alright, so there we go, zero error, and that's what happens when you go to zero it. It goes to 999.99 dB, which obviously is not correct. So what we'll do now is I've gone ahead and hooked up this just to make things easier. I know this is not the ideal setup, but it'll work for testing. I've gone ahead and put the reference attenuator in line with the sensor, and I've got that fed back through this coax to the reference power port on the power meter. And so now we'll go ahead and run the cal, and we'll cal the unit to minus 30 dBm. So we've got the LED lit there, putting the reference calibration signal on the sensor, and there's our cal error. Okay, and so now, so we've seen that we can't zero it, and we can't seem to calibrate the sensor either. But here's the funny thing. So I've gone ahead and set up on my signal generator. I've got a 50 megahertz signal at minus 20 dBm, and feeding it through this relatively long piece of coax into the sensor port, and the power meter here is showing minus 20.33 dBm, which you know, I don't it's reasonable to assume at least a 0.3 dB of signal loss in that cable. So you know, so what's going on with this thing? So we'll go ahead and we'll take it down to minus 40 dB. So we've got a minus 40 dB signal, and we're showing a minus 40 dBm signal on here. And we'll go ahead and try to take it down to the full range. Now, you know, you're not going to get the full, you know, minus 70 dB. We'll see what we can get out of it. We'll go ahead and put it there at minus 70 dB, and we're getting about a minus 59. Now, when this thing was working, when this sensor was fully working, about the best I could get reliably was about a minus 65 dB on the signal. And of course we're not getting that either. Now we're getting minus 58.6 dB. So let's put it, we'll go back here to minus 20 dB, and we're back at our minus 20 dB. So it's interesting that we can't cal and we can't zero, but for some reason the signal seems to be working. So, and here's what I suspect is going on. The manual talks about ways to check the manual goes through a troubleshooting process. It's a block troubleshooting process, and it isolates a fault in the sensor to a section. Right here it talks about the A1 bulkhead assembly supplies approximately minus 5 millivolts when RF output is 10 microwatts, which would correspond to the minus 20 dBm of signal. So what we'll do is we'll look at the signal up here on the multimeter. All right, so we're going to take that reading now, and on the schematic we're going to look at pins 1 and pin 9 of the A1 bulkhead assembly. So we'll take a reading on pin 1 and pin 9, and if you look at the multimeter, we're looking at minus 4.9 millivolts DC, which is according to the manual where it should be, approximately minus 5 millivolts when the RF input is 10 microwatts. So we know that we've got our bulkhead assembly is putting out the right voltage, and based on the fact that we're reading a correct voltage on the power meter, we can, you know, it's relatively safe to assume that the rest of the circuit is working. If there was a problem in the amplifier circuit further on down, looking at the schematic, so if there was a problem in the amplifier circuit down here, the input amplifier, then we wouldn't be getting a signal out at all to the power meter. Obviously the sampling gate and the input amplifier assembly is working correctly, because we know that the bulkhead assembly is working because we got the approximately minus 5 millivolt signal at a full power input signal, so we know that that's working correctly. And we know that the input amplifier is working correctly because it's producing an output to the input amplifier, which is producing an output to the power meter, which corresponds to the correct power level. So, why will this unit not zero then? Well, here's what I'm thinking. So right down here is this is the bulkhead assembly going into the power unit, and there's two very tiny gold wires that come out of the bulkhead assembly. You can just see one right down there, and there's one right down there, and they're held in place by this little I guess for lack of a better term, it's just a little friction mount. This little plastic clamp and the screw clamps those leads down onto the input amplifier, or I don't know what they call it here, but the A1 amplifier here. So what I suspect is that when this unit was submerged with really nasty rainwater, that we got some crud and junk down in here, and it's settled in there and under those leads, and it's making us have a bad connection. Because that to me, at least my way of thinking, that could be the only thing that's causing the problem. Since we're able to read high power, and it makes sense because we're able to read high power signals, but the low power signals, when you're down into the nanovolt regions, they would really be affected by just the smallest amount of anything, crud or corrosion down there on those terminals. They would be affected by that signal. And if there's any kind of any small amount of bridging across those contacts because of any kind of deposits down there, then that could be causing us to have zero and not be able to zero the sensor. So what I'm going to do is I'm going to go ahead and take this unit apart, and I'm going to get in there and clean it with some isopropanol alcohol, and we'll see what we can do from there. All right. So here is the assembly now. We've lifted this little piece, this clamp, and you gotta be careful. There's a little spring there on the clamp, and if I can get it in focus, there's the so there are our two leads. Right here are two gold leads. Now the manual talks about when you disassemble. If you disassemble this, there's two things you gotta be careful of. One, that you don't when you reassemble it, you don't screw this this clamp down too tight because they're worried about cracking the clamp or causing a bad connection. And two, that you absolutely do not touch these gold leads with your bare hands, because your skin and body oils will get on there and they will affect the performance of the power sensor. So what I'm going to do is, off camera, I'm going to go and I'm going to look at this under my microscope and get a good look at the pads and the leads, and then I'm going to clean this with some alcohol. And once I get it cleaned, I'm going to do that off camera. And once I get it cleaned, then I'll bring it back and we'll see what if it's working better. Okay, we're back. So interesting little twist of events here. As I was taking this unit, as I was taking the bulkhead assembly off here, one of these gold leads, this one right here, was broken. I don't know if that was due to some corrosion due to the water intrusion, or if it was already maybe broken through partially due to fatigue. But as when I took the clamp assembly, or not the clamp assembly, but rather this little ferrite. These are little ferrite beads. This little housing here, as that was coming off, one of the leads on this bulkhead assembly came off, and it broke just right here. I don't know if you can see that. Had enough lead still protruding that I could reattach it with very carefully with some solder. So I've reattached the lead. I don't know if that may affect the unit. I'm sure in some lab somewhere it probably would, but for my purposes, I think it'll be okay. The big thing now will be getting these leads relanded to the pads here. These two pads here and here, which I have cleaned off. They looked in fairly good shape. I didn't see any dirt or anything on them, but cleaned them off anyway. So we'll put the ferrite bead housing back on. We'll get the leads in position, and we'll get the unit put back together. Alright, so one last look. Here is our unit. It's all put back together. I went ahead also and did the same thing to the other sensor I had. It did not have a broken lead, so that one didn't require any soldering, but went ahead and cleaned the surface on clean the surface for the connection pads down there and put it back together. So what we'll do is we'll go ahead and reassemble these units, and then we're going to do some testing. So I found something kind of interesting, and I haven't really looked into it much to see, but as you can see here on my desk is an HP 8482 power sensor, and it's hooked up to my power meter. And when we go to 0, the power sensor and the unit will 0. Now we'll go and attempt to 0 this 8484A sensor. Alright, so now we've got the 8484A hooked up, and just like before, it's still showing over range at 999.99 dB. So we'll 0 that. And what's going to happen is we get the same error. So we've taken the unit apart, cleaned it out, and it's still showing a 0 error on the instrument. So what I'm going to do now is, you see I've got my HP 453B power meter set up. So what I'm going to do now is I'm going to hook this 8484A into this analog power meter, and we're going to 0 it on this one. I'm going to show you what I found here. Alright, so we've got the unit hooked up now to the 435B, and we hit the 0 button, and we can see that the power sensor appears to be zeroed at this point. So what I'm going to do now is we'll attach the reference signal. Alright, and unlike before with the Agilent the 4418B power meter, on the 435 we can in fact cal the sensor. So this sensor has a reference cal of 95, and our switch is set to 95, and we can very carefully adjust to get that just into cal right there. So using the 435B, it appears that the sensor is working. So what I'm going to do now is I'm going to set this this sensor up to the signal generator, and we'll run some tests using the signal generator. Alright, so just to get rid of any losses in the cable, I've gone ahead and hooked the unit directly to the signal generator. We've got our signal generator set for 3000 megahertz, 3 gigahertz, with a RF output of minus 20 dBm. So I know based on the label on the sensor that we need to set our cal factor to 94, so we'll do that. And we'll go ahead and adjust our range to minus 20 dBm. And we'll put the RF on, and there is our RF. It's just ever so slightly overranged there. So what that's telling us is that our the power going in is just ever so slightly above negative 20 dBm. So we'll bring it down, negative 21 dBm, and there we go. So we'll bring it down, so it's just a little bit above minus 20 dBm. Alright, and I'm going to go ahead and work the attenuator down. So we're going to go down to negative 30 dBm, and as you can see, we got right on the dot, negative 30. We'll go negative 40. And we'll have to move the range switch. Again, right on the nose, negative 40. Alright, so now we're at negative 50. Again, so that will be negative 40 and 10 is negative 50 dBm. Alright, take it again. Now we're at negative 60 dBm, and we're looking at our power meter again, just right on at negative 60. Actually, in this case, we're just a little bit over negative 60 dBm. Take it to minus 65 dBm. Alright, and now we're going to start getting into where the sensitivity on where it's really sensitive up here. So we're looking at negative 65, 66, 67. So the power meter showing negative 67, and our frequency signal generator showing a negative 65 dBm. But like I said before, with these sensors, you know, about minus 65 dBm is really the floor as far as where you're going to get any noticeable change. I'll go ahead and take it to negative 70. So we're looking at now negative 70 dBm, and we'll see what the power meter shows us. So there you go. You can see there's a little bit of lag, and you know, we'd have to let the sensor sit here for a little bit. I don't know. But really, I think, like I've said, the negative 65 is really the bottom of the range that we're going to get. So again, looking at right at negative 67, just right at negative 67 dB. So, all right, and just real quick for the other sensor, go ahead and zero it as well. So that's zeroed, and we'll go ahead and hook up our reference signal. All right, and bring that up. All right, and this one is a reference cal of 100%. So we got our knob set to 100% now, and we'll bring that cal adjust. Bring that just right into cal, right there. All right. So for 3 gigahertz on this sensor, we're at 98% on our cal factor, and I got the signal generator set again for 3 gigahertz at minus 20 dB. So we'll turn our RF on, and we are looking at, again, just slightly, ever so slightly over for 0, so we'll bring that down a little bit. Alright, so we'll go ahead and take it down to minus 30 dB. So we're looking there at minus 20, 10 again. Remember now, this is the other sensor. We'll take it down to minus 40. Alright, again, right on. Minus 50. Alright, again, right on, minus 50 dB. Minus 60 dB. Alright, so not quite, just a little bit over. We'll take it to minus 65 dB. Alright, now again, and so we're at minus 65, so that's 55, and again we're a little over. So we'll take this to 60, and still showing over. So 65. So that's showing a minus 70 dB. We're set for minus 65, so we'll take this back to minus 60. Alright, so right now our attenuator is set for minus 60 dB, and we're actually showing a minus 61. So somewhere, and I'm just going to scroll the attenuator on the dial, and we'll see where we start getting this kind of response. So we're at minus 61, showing minus 62 on the meter. Alright, so now we're minus 62, minus 63, that's minus 64, so it looks like about minus 64 really starts to kind of come off the scale there as far as being on track, because that's again showing at minus 65 dB, and we're showing on the meter that we're already at minus 70. So this sensor appears to be not as well operating below. Appears to be not operating as well at the lower power levels, and I'm kind of not surprised about that, because you know, I started taking this one apart, and I could tell that somebody had been in it before me, and so there's a good chance that it was at some point serviced or repaired, or some part replaced. You know, it's kind of what you run into when you buy this kind of stuff secondhand. But anyway, it would seem that this other sensor here works much better, and so I'm glad at least I have this one sensor that's working, and we've got the other one, which is questionable, but it's still good, at least down to minus 60 dB, so it could be useful. But anyway, so that's it for this video. I'm gonna have to look into why this meter doesn't want to play nice with these sensors. I know these are the older version of the 84A sensors, which are in themselves long obsolete. I'll have to do some reading. I guess maybe it's possible that this power meter doesn't work with the older version of these 8484As. I can't remember if I've ever used the sensor with this power meter. I just got this power meter recently, and it may be that it's not. It may be that they never worked with it. I can't remember if I ever used it or not, but I'll have to look into that. The only other way for me to check is to get my. I've got an old HP 438A, one of the old digital dual channel power meters, but it unfortunately was also submerged in the flood, and it's going to have to be cleaned out, taken apart and cleaned before I can get it up and working again, assuming that it will work. But that's all for now. Thanks for watching. Like I said, sorry I've been out of the video making videos for a while. I do have projects in mind. There will probably be some additional repair or troubleshooting videos coming up, just based on the nature of my lab and the equipment. But I hope to eventually get back to my other projects, including finishing the curve tracer that I was working on. But just check back, and I'll get out some new videos as I can. Thanks.